Hello and welcome to this tutorial. In this tutorial you're going to create an editor window in which you'll be able to extract animations automatically from all the sprite sheets that you provide. We're going to extract animations for a 2D pixel art character and we'll make him look handsome with some good looking beard. As you can see in the art folder that I have here, I have 14 different variations of a beard, and here I have a character. And for this character, all the images or all the animations of the beard matches to the character's animation. For example, for the first row for the character, the first row for all the beards is applied. For the second row, it's empty in the beard.png because the character is not looking towards the camera, and it makes sense that those are empty. And we're going to create an editor window which will help us extract all the beard animations and all the character animations so that we can pair them up and that we can use them in our game. Now, let's get started. First, let's create the C# script, but before that, let's create the scripts folder. You're going to create a new C# script called Animation Creator Window. Of course, that needs to go into the editor subfolder because we're going to create an editor script. Let's open it up. This is not going to extend from MonoBehavior, but from the editor window. And let's create the window first. Public static void show window, and we're going to call get window animation creator window. Okay, there's a typo here, and we're going to call it animation creator. We're going to call this menu item window animation creator. Simple enough. And we just wait for this to recompile, go to window, and there it is, animation creator, and the window is created. Now let's go and add some fields that are required for this to work. First, we're going to add two simple fields, private vector2 scroll position, because this window will be scrollable, and we're going to create private serialized object. You'll see why in a sec. We don't need system numerics. We don't need these usings for now. And let's create an ongoing method that will draw a label, animation creator, and we're going to make it editor styles dot bold label, and we're going to do scroll position equals editor GUI layout dot begin scroll view, and we're going to pass the scroll position here. Then we're going to do if serialized object is equal to null, we're going to say serialized object equals new serialized object, and this is going to be the actual serialized object. Then we're going to add the end scroll view, and we're going to serialized object that apply modified properties. And this is the simple thing for now. Let's go back to our art folder and to see how our sprite sheets actually look like. In here, we see that we have maximum of 8 sprites per animation. That means that the width of our sprite sheet is equal to 8. And in here, to save us time, I've counted, and there's 49 different animations here. And of course here, per single beard, we have 8 times 49 sprites. So that means that there's 14 different beards. That would take us to around 5,488 sprites, which is quite a lot. In the import settings of the beard, it's set to be grid by cell size 32 by 32, and the rects that are empty need to be kept because we need to map them properly to the animation. Now, as I already mentioned, we're going to write some code here, some fields we're going to introduce, like public int sprite sheet height. As we already said, it's 49, and public int sprite sheet width is going to be 8, and we're going to write frame rate, which is how many frames per second do we want. And I was prototyping and think that 12 is more than enough. Okay, let's now add those fields to the editor window. And we're going to serialize object.find property, and we're going to call name of and sprite sheet height, for example. And then we're going to do sprite sheet width. And why am I doing name of instead of the regular strings? Because name of is much more stable, because if I'm here and try to change this to something else, it would automatically update the field here. But if I were to do it as a string, it wouldn't work properly. I would have to manually update it here. Let's just get it back to height. And of course the frame rate. Everything here seems simple. Now we're going into a bit of a juicier part, so to say. As you can already see, characters will have the exact same animations as beard, or not animations actually, but the states they are going to be in. The transitions are going to be exactly the same, and animations clip are only going to be different. Everything else will be the same. The state machine will be the same, parameters will be the same, everything. So the way that I approach this is that we have different settings for the override controllers. So we're going to create override controllers for each and every beard, and we're going to create the main animator controller that all the beards are going to override of, and that's going to be the character animator controller. So we're going to create a new class that is called Sprite Sheet Animation Export Settings. That is just a plain old C# class, and we're going to make it serializable. And what I would do is that I like to have the field serialized field property here, because let me just serialize field public default asset export folder, because this way I get to get the value of the field, but at the same time it's private and can only be set through the editor, which is what we really want. I'm going to create another serialize field. I don't know how to type, obviously. String animation prefix. So for each animation, for example, for a single character, we're going to have the character prefix. For the beard, we're going to have beard prefix. And if we later on add hair or some clothing, then we can prefix those with the designated prefix as well. And of course, we need to add the public texture 2D, and that is the actual sprite sheet that we're going to transform into the animations. As I already mentioned, we're going to have a single animation for the character. So it's going to be original animation export settings. But later on, we are going to add a bunch of other animations for hair, for clothing, and stuff like that. So we're going to make an array for the override sheet export settings. Alright, sprite sheet export settings. Let's make this so lowercase. Now we're going to add 2 spaces to logically differentiate different parts of the class, so to say. But we're still going to use the property field because property fields do everything that we want. They're drawing the arrays, they're drawing the serialized object the way we want it, or the way they're already drawn in the inspector when you add a component to the game object, so that we don't complicate unnecessarily some stuff here with drawing custom inspectors. And this so far should be it. We have the original animation export settings and we have the override sprite sheet export settings. This part so far should be fairly straightforward, but now we are going to the juicy part. Button. We're going to add a button called create animations. Now we're going to create a method called create animations and animator controller. And that method is going to take the single sprite sheet animation export settings as a parameter. And it's going to have a flag that will ask, or that will know if that is an override animator controller or it is an original animator controller. Because here we're going to pass the original animation export settings, we're going to say that this is false so that we don't have the override for we don't create the override for this instance. So we're going to say here is override, and we're going to call this just settings. And now we're going to iterate through all the settings here. So let's go for E is less than override settings length. We're going to save our settings equals override sprite sheet export settings of I. And then let's just make a small display editor utility, display progress bar, and we're going to call it creating animations, and then the info will be creating animations for. I'm going to use the string interpolation settings.spritesheet.name because that's the name of the file that we're using to create the animations for, and the progress is going to be float of I slash override dot length, and that should be it. And of course we're going to call this method create animations, and there's an and missing, and animation controller. We're going to pass these settings, and we're going to say that this is an actual override. For now, we can just simply call the debug log so that we know that this works. We can call this settings.spritesheet.name and is override, just to test it out. Let me first create a folder called animations, and in animations I'm going to create a folder for beard and a folder for the character. For the character, I'm going to drag it into the original animation export settings, and I'm going to create an array element for the beard. We're going to call this beard. We're going to add the texture for the beard here. We're going to add the texture for the character, and we're going to call this the character. And when we click the create animations, we have this creating animations for beard, and it's not moving out because we haven't cleared the progress for the display progress bar. Clear progress bar would do just that when we click the create animations button once again. Let us just recompile the program, and it says it's busy, but it's not. And now you can see that we have the character false because character is the original animation export settings, and that beard is true because it is an actual override. Now let's start and write the create animations and animator controller method. Let's dive and write the actual implementation for the create animations and animator controller method. First, what we need is the path to the sprite sheet. We're going to call the asset database dot get asset path, and we're going to call settings dot sprite sheet. Next, we're going to call var all sprites asset database dot load all assets at path, and we're going to call sprite sheet path. This will return all the sprites that we have for the beard.png. This method can sometimes be misleading because load all assets at path, you would think that if you point, for example, to the art folder, that it would get you all the sprites from all the sprite sheets that you have created here, but that's wrong. We're going to create an additional method later on. This load all assets at path only returns the sub-assets of the asset that you have passed the path here. So here we're going to return only all the assets that have been loaded that are sub-assets of the beard or the character. But unfortunately, this is not enough because sometimes Unity really likes to mess with some of this implementation. For example, if we load all assets at path, you would think that it would load all the sprites sequentially. Like this is the character 0, 1, this is the character 0, this is the character 1, this is character 2, 3, and so on and so forth. And you would think that they're all going to be loaded in order, but they're not. And that is why we need to create another method in a class called sprite sheet name comparer, because we will need to order all of these by ourselves, because Unity sometimes just likes to load them in a random order that I really do not get. Actually, it's not going to be sprite sheet name, but sprite name comparer, because we're going to compare names of the sprites and not the names of the sprite sheets. We're going to implement the iComparer interface, and of course we're going to implement the method. And now what we need to do, because our character's name is character 0, character 1, etc., we need to compare them in such a way that we only pick up only the last digits after the underscore, after the last underscore, because maybe sometimes later we're going to get some weird assets name like beard main 1 and stuff like that. So we're going to use something called regex or regex, and we're going to create a small helper method to help us with that. We're going to call it private int extract number, and we're going to pass the input for the parameter, and we're going to write match equals regex dot match input, and this is the regex that we're going to use. We're going to place at here so that it avoids all the escape signs. We're going to place underscore / d plus. We're going to open another bracket dot star underscore / d plus, and this is the regex that we're going to use. This regex matches so this regex basically says if this is the only underscore that we have here, that's fine, just give me the last digit that it's there. If it's not, then just get me the last digits actually, because we're taking all the digits after the last underscore, and that's it. And we're going to say if match.success, we're going to parse it, so int.parse match.groups of 1 .value, and that would give us the actual number that we need. Otherwise, we're just going to return -1. I don't want to break something, so I'm not throwing any exception or stuff like that. And now it's just plain simple to compare these numbers. or the strings, we're going to call return extract number of x dot compare to extract number of y. And that's it. Now let's get back to this implementation. All sprites equals asset database, load all assets at path, sprite sheet path. Here, as you can see, Rider is telling me that it's returning the array of objects of Unity engine.object, and that is something we don't want. We want all the sprites to be actually sprites and not objects, and that is what we're going to cast all of the assets that we're loaded to Sprite, and we're going to do it by typing dot of type Sprite, and after that we're going to do the order by, because we need to order them in the way the numbers are written in the Unity engine itself. So it needs to go from 0 to the max number in the sprite sheet, and we're going to order them by name, but we're going to call the sprite name comparer as the class that's going to compare the numbers. And we're of course finally going to switch this to array so that it's not an ordered enumerable of type sprite, but it's going to be an array of sprites. Now comes the hardest part. We're going to create a function that will convert a 1D array into the list of 2D arrays that we're going to store on our drive as animations. First, let's create a class called extension methods. That class is of course going to be static because we're going to create an extension method. We're going to call it public static list t open brackets convert 1D array into 2D array. We're going to have this t array, and we're going to have the width and the height. Of course, we need to have the t as a generic parameter here, and we need to import the list from the systems.collections.generic. Now let's define some variables here. First, we're going to have the number of elements, that is the total number of elements in the array. That's of course our array.length. Then we're going to add the number per 2D array, number of elements per 2D array. That's width times height. That's the total number of all the elements. So let's call it total number of elements per 2D array. And we're going to have the number of 2D arrays. That is the actual total number of the 2D arrays, as the name implies. And that's going to be number of elements plus numbers per total numbers minus 1. And that's going to be divided by total number of elements per 2D array. We're going to write this down and then we're going to explain everything. So we're going to go through the for loop for current array number equals 0. Current array number is less than number of 2D arrays. Current array number plus plus. We're going to create a variable here called row offset. It's going to be 0, and we have the current array. That's going to be new t of height and width. Of course, we forgot something here, and that's the actual result, or the array of 2D arrays equals new list of t, and it's going to have a capacity of number of 2D arrays. Let's call this actually the list and not the array. List of 2D arrays. Then we have two nested for loops inside of a for loop. I know that's a bad practice, but this is the way how it's done. E is less than height, E plus plus, J is less than width, and here we're going to say current array of I of j equals array of I plus current array number times width plus row offset plus j. And after this is finished, we're going to row offset plus equals number of 2D arrays times width minus 1. List of 2D arrays dot add current array. I'm going to return the array or list of 2D arrays. Sorry. And this is the method. It looks really simple, but it was really hard to come up with the actual solution. Let me demonstrate how it's working. For example, let's say that we have numbers in a single array. 1, 2, 3, 4, 5, all the way up to 16. And let's say that we want to have arrays dimensions 4 by 2. So they are going to be in width 4 and in the height they're going to be 2. So that the end result would look something like this. 1, 2, 3, 4. And this is going to be 9, 10, 11, 12. Because that's essentially what we're going to do. First, let's write all of these elements here, and let's say that width is 4 and the height we want is 2. Number of elements is going to be 16, as we already discussed that. Total number of elements per 2D array is going to be 8 because we're going to multiply these numbers. That's going to be 8. And the number of 2D arrays is going to be number of elements, which is currently 16, plus, let me just write this down, num, that's going to be 16 plus total number of elements per 2D array, that's going to be 8 minus 1, and that is 23. And we divide that with total number of elements per 2D array, and that is 8. And 23 divided by 8 in the integer division is 2. So that's it. We have two arrays. Let me create a new canvas. So we know that we have the number of 2D arrays, that is 2, and we're cycling through this. Row offset is actually the row that we want to put our new animation on. So for example, when we finish this cycle, we want to put the next animation into the next row, and that is the row offset. Now we cycle through this, and let's say that we have the first array, the first 2D array that is completely empty. That is the current array. And let's divide it here. 1, 2, 3, 4. And let's add another one for the second. 1, 2, 3. I'm terrible at drawing, as you can see. So let's say that I equals 0. We have this. Let's copy and paste this array here. Let's move it down here. Let's delete this. We're going to have, let's do it like this. It's going to be much more convenient. Let's move this one here. We have I that is equal to 1, to 0, sorry. We have j that is equal to 0. we have row offset that is equal to 0, and we have the current array. That is all we need. And of course we have the width that is 4, and we have the height that is 2. Now let's begin. When I is equal to 0, we say that current array of I of j, that is 0, 0, that is this element here, equals the array of I, which is 0, plus current array number, which is still 0, times width, anything that multiplies with 0 is 0, plus row offset, which is 0, plus j, which is 0. So we take the first element, and that is here 1. Next, we populate this. This is easy. 1, 2, 3, 4, because I is 0, and row offset is 0, and this is automatically 0 because current array number is 0, so we populate this easily. We exit the nested for loop, and we add to the row offset the number of 2D arrays times width minus 1. Number of 2D arrays, as we already know, is 2, times width is 2, that is 4, minus 1, that is 3. So row offset is now not 0, but it is 3. Now let's go back to the nested loop. Current array of I of j, I is now equal to 1, so we need to populate this part here. And we're going to say that current array of I of j is array of I is 1 plus current array number, that is 1. So that is already 2. Let me write this down. Oh, sorry. Current array number times width, that is 1 times 4. That is 1 plus 4. That is already 5. That is already 5. Plus the row offset that we have set here is 3. That is plus 3. That is already 8, and plus j. J is 0 for the time being, and we're accessing the 8th index. 8th index in our case is number 9, because we're going from 1 to 16 and not from 0 to 15. And because only the j is increasing in this nested loop, we're going to go like 9, 10, 11, 12. The same goes for this second array. It's going to be 5, 6, 7, 8, 13, 14, 15, and 16. And that's it. That's all there is for this method. I hope that it's clear enough. If it's not, please let me know. Now let's get back and implement the method that we wrote here. We're going to call it sprites in matrix equal all sprites dot convert 1D array into 2D array, and we're going to call this sprite sheet width and sprite sheet height. And there we have it. We have all the sprites populated in the corresponding matrices. Sorry. Before we continue with this method, there is one class that I forgot to implement, and we're going to do that now. As you already know, all of our animations are going to be the same in terms of the names and what they're actually doing. The animation for the character walking down is going to be translated to the beard animation as well, because all the beards will have the same animation. So they will have the walk down, walk up, walk right, walk left, etc. And that's why we need another class that is called common animation data, in which we will be able to provide all the necessary information for the animation itself. We're going to call this class common animation data, and it's going to be serializable, of course. And of course, we're going to have the field serialize field. I'm never going to learn how to write this. Serialize field public string animation name. It's going to be get private set field serialize field public int column offset, and again field serialize field length. Length is the actual animation length, and for most part it's going to be 8, but some animations have 4 or even 1 single frame. And that's it. Let's now integrate this common animation data into animation creator window. Public common animation data, and we're going to call this common animation data. And that's it. Now let's get back to the sprites in matrix where we left off. We're going to call this for loop for int e equals index less the sprites in matrix dot length or dot count. We're going to have var sprites equals sprites in matrix of index. And now what we're going to do is we're going to finally create animation clips, and we're going to create the animator itself. Because for each individual animation data, we're going to have to create the animation clip for each individual animation that we provide as the animation name here above. Maybe it doesn't make sense yet, but when I show you how to use it, it's going to make sense. Now let's type here for var e equals 0, e less than common animation data dot length I plus plus, and we're going to call var data equals common animation data of I. Now we're going to have the editor utility dot display progress bar, and we're going to say creating animations, and we're going to call the creating animation clips for sprite sheet settings dot sprite sheet dot name, and the progress is going to be actually the float index of sprites in matrix dot count. I mean, what we can do here is we can call something like index and sprites in matrix dot count. Now we're going to create the create animation clip method. That method is going to receive a lot of stuff. It's going to receive the actual sprites. It's going to receive the settings dot animation prefix. It's going to receive the data dot animation name, and there are more parameters to come. First one is data dot column offset. The second one is index dot to string. Then we're going to have the data dot length and settings dot export folder. I will explain each and every parameter as we write this method up. And when we finished creating all the animation clips, we're going to have the method called create animator, which is responsible for creating the actual animator, and that one is going to take only 3 parameters: settings, index, and is override flag. Let's create it really quickly, because that's the method that is going to take slightly less time. We're just going to check here, for example, if is override. If we are not creating the override animation controller, we're just going to go and say var animator controller. It's in Unity editor dot animation namespace. No. Dot create animator controller at path. The animator controller path is actually going to be written above, and we're going to call it animator controller path, and it's going to be asset database dot get asset path settings dot export folder. We're going to create the animator controller in the export folder, and we're going to call it settings dot animation prefix underscore index, because beards, for example, are going to be in the index, are going to be separated by the index themselves, and we just write dot controller because the extension for the animator controller and animator override controller is dot controller. So if this is the override, if this is not the override, we're going to call animator controller path, and we need to have the location of the animation clips. So that is going to be done a bit later. First off, let's create another method in another script. We're going to call it editor utils, because as I already mentioned, the asset database that load all assets at path is not doing what you would supposed to be thinking it's doing, because load all assets at path only loads the assets that are inside of the provided object and not inside of a folder, for example. Only the assets that are inside of an object, for example, a scriptable object, or in our case here, the sprite sheet, only they are going to be loaded. So we need to create another method that is going to get us all the necessary animations or animation clips or any other type from the folder that we pass it as a parameter. Let's write it here. Let's call it public static, and it's going to be generic because we're going to provide the type ourselves. Load all assets of type from folder. T is going to take string path, and it's going to take additional query, and query is going to be an empty string, and we need to add where T is equal to Unity engine dot object. You will see why in a second. Asset database has a really convenient method that is called find assets, and find assets essentially emulates this search box here. As you may know, we can find all assets of a certain type by typing T and saying, for example, Sprite, and it will load all the assets of type Sprite. Same goes to the hierarchy as well, but we're only interested in the search box here. So asset database.find assets is actually being called internally here. So that's what we're going to leverage. We're going to call return asset database.find assets, and we're going to have the interpolated string. It's going to be T and then the type of the type that we have provided, but type of returns the full namespace and the name of the class. So we're going to call type of t.name, and that is going to return just the actual name that we need. Additionally, if we want to search for a specific asset, we're going to pass it to the additional query, and that's it. The second parameter here is the list of folders in which we need to look at for specified assets. And this is going to be really simple because we already have the path, and that path is going to be passed here, but we're not returning the array of objects yet because we only found the assets themselves, and they're the list of strings, and those strings actually represent the GUIDs, and they're not very useful, but now they're going to be, of course. So we're going to type in dot select x asset database. Also has a convenient method, load asset at path, and that method is going to give us the correct asset that we provide here, but we don't know the path, and that's going to be asset database dot GUID to asset path, and we're going to provide x here, and this is going to list us all the assets of a certain type that we have provided, and we just need to convert it from an enumerable to array, and that's it. If we want to return a single object, for example, we also can do that. Load asset of type from folder is going to be type of t, string path, string additional query, and we're going to return this fella right here. We're going to pass path and additional query, and we're going to return the first or default. Of course, we shouldn't forget the constraining that we have here. Okay, that's it so far. There's a lot to cover. Again, let's go back to the create animation clip. Let's go back to finishing the not overridden animator controller, because that's going to be a bit more simpler. We need to retrieve the original animation clips here, and we're going to do that by going to editor utils that we created, and we're going to load all assets of type from folder, and that's going to be of type animation clip. And of course, we're going to pass original animation export settings dot export folder. And we're going to do the asset database, of course, get asset path, and that will get us all the animation clips that we have for the original animations. And I know that we're going to have them because we're creating animation clips prior to creating the animator. And now with this animator controller that creates the animator controller at path, it's going to create the actual asset for us. And after that, we're going to go through the original animation clips and we're just going to add them. So animator controller that add motion, and it's going to add the animation clip itself. And that's essentially it. We cannot test this yet because we still need to implement the create animation clip method. So let's dive into that. First, we're going to create the actual clip. It's going to be var clip equals new animation clip, and it's going to have the frame rate of the frame rate that we have above set in the editor, and we're going to have the wrap mode equal to loop. Next, we need to extract the animation clip settings from the actual animation clip file, because otherwise we will not be able to set the loop time in the animation itself. So let's go and type animation utility dot get animation clip settings, and we're going to pass the clip. Then we're going to set clip settings dot loop time equals true. That means that the animation will loop constantly. And when we did that, we're going to go and set that back. It's going to be animation utility dot get set animation clips, and we're going set animation clip settings. Sorry, clip settings, and that's it. That way, our animation is going to loop always. Optionally, you can always go into the common animation data and add that flag here so that you know that which animation you want to be looped and which ones you don't want to. Now let's type var sprite binding equals new editor curve binding, and we have 3 fields here to populate. The first one is type. The type is sprite renderer because we want the type to change is the actual sprite renderer. The path is going to be an empty string, and we have property name equal to m sprite with big S. That way it will ensure that we're actually changing the sprite renderer's property sprite with this sprite binding. Next, let's create sprite keyframes. That's going to be new object reference keyframe of length. That's going to be an actual array, and we're going to populate it with for var e equals 0, e less than data length, or just length, e++, and we're going to say sprite keyframes of I equals new object reference keyframe, and that is going to be time equals I divided by clip dot frame rate, or just the frame rate, and the value is going to be the actual value here, that is sprites of starting index, and I is the second parameter, and starting index is actually the column offset. Now we can go and go to animation utility dot set object reference curve clip sprite binding and sprite keyframes, and this will create the actual animation for us. Now, because the animation clip is now successfully populated, we need to save it somewhere. And we're going to use asset database dot create asset clip, and we're going to have this, of course, asset database dot get asset path, and we're going to have the settings export folder. This is going to be target folder. This is going to be prefix. This is going to be animation name. Oh, sorry. This is prefix, and this is going to be a suffix. Get asset path, and the asset path is going to be target folder, and we're going inside of that folder, and we're going to create it like this: prefix, animation name, and we're going to add the suffix dot anim, and we're going to go to asset database dot save assets and asset database dot refresh, and that's it. This create animation clip method is successfully created. But now comes another semi-tricky part, so to say. It's not that hard, but it's not super straightforward as well. We have the animator controller path, which, as we already know, gets us the actual path for the animator controller that we're going to create. We have created it here for the non-override. Now we need to have it for the overridden animator controller. But first, we need to go and grab the original animator first, because the original animator, we know where it's located. It's located in the original export settings export folder, and we're going to get it with the editor utils that we have just created. And we're going to say load asset of type from folder, and we're going to say it's animator controller. And what path is it? It's asset database that get asset path, and we're going to say original animation export settings dot export folder, and that would get us the actual animator controller. Next, we're going to create the simple override controller. It's going to be called new animator override controller, and we're going to say that runtime animator controller is going to be the original animator that we have just referenced above. Now comes the first semi-tricky part, and that is the overridden animations. Because we have already successfully created all the animations that we need in here, we need to load them back. And how do we differentiate those animations from each other? So editor utils dot load all assets of type from folder. We're going to load animation clip, sorry. We're going to call asset database dot get asset path of settings dot export folder, and we're going to add the additional query of index dot toString. How do I know that this is going to work? Well, it's pretty simple. Let me just demonstrate it. Let's say that in a new folder called animations, we have, let's create a scene. Let's say this scene is called scene 0. Let's say we have another scene, or let's call a material. It's going to be material. And let's emulate what we're going to do, like material walk down 0. Then we're going to create another material called material walk down walk up 0. Then we're going to create another material called material walk right 0. Then I'm going to duplicate them all, and I will just remove the 0 and we'll replace it with 1 walk right. And now if I go here and type T material, I'm going to get the folder animations. And if I press 0, that's going to give me all the animations. Let's say these are animations. It's going to give me all the animations for the specified index. If I want the animations that end with the index 1, we're going to get those. And those map perfectly with the animation, with the animator controller that is going to be created. Let's do var pairs equals original animation clips dot zip overridden animations, and we're going to create a lambda original overridden new key value pair of animation clip, and it's going to be original overridden controller dot apply overrides pairs dot toList, and that's it. Asset database dot create asset override controller animator controller path asset database dot save assets asset database dot refresh, and this is it. This is the end of the coding session. So let me just go briefly through this create animator method once again to explain everything. We have the animator controller path. That is the path for the current animator controller. That can also be the original one, but we don't care. Original animation clips are the original animation clips that we need to use in two scenarios. The first scenario is to add them to the original animator controller that we create here. And later on, we need them so that we can create the override animator controller that we're doing here. So here we create the new override controller. We pass the original animator here, and the overridden animations are loaded as I already described, and we are pairing them with the zip function. Zip function essentially is doing this. Let's say that we have two arrays. One array is 1, 2, 3, and the other one is 4, 5, 6. The zip function will, if we call 1, 2, 3 dot zip with 4, 5, 6, this is going to produce the following result. It's going to produce an array, or I enumerable to be precise, 1, 4, 2, 5, and 3, 6. And that is exactly what we want. We want to pair each element of its corresponding index with the second element of the second array, with the element in the second array. And that's it. So now let's give this script a quick test. We have the animation creator window here. We have the sprite sheet height to 49, sprite sheet width to 8, frame rate is 12. We have characters. Export folder is set to character for the character. We have the beard folder for the beard. And now let's click run and see what happens. It created everything except for the animations. Of course, it didn't create any animations because I haven't defined any of them. So let's dive in here and duplicate this and add the common animation data array here. And we have common animation data here. For the sake of simplicity, we're only going to have two animations. The first is walk down, sorry. Walk down, column offset is 0, length is 8. Walk up, that is the column offset of 1, because as you remember, the column offset is for walk down is 0, for walk up is 1, for walk right is 2, it's going to have the length of 4, this one is going to have the length of 8, and let's create the walk left, because why not? And then the column offset here is 3, and the length is, oh, it's still 8, I'm sorry. So all of these have to have the length of 8. And now, if we click the create animations, we should be presented with a bunch of animations in the beard, and we're going to have only 4 animations in the character. Let's test this out. First, let's create an empty game object called character holder, for example. And let's create a 2D object sprite, make it a triangle, it doesn't matter. We can add a component called animator, and we can drag here the character. Of course, we can call this body, and we can add another game object called beard. And let's assign the beard here. Let's remove the gizmos so that we don't see them. And if we press play, let's hope that everything is working properly. It is. The only issue is that the beard needs to have the slightly bigger ordering layer so that it's always rendered on top of the character. And there you have it. I know this was a super long tutorial, but I was really trying to cover everything that there is to creating such an interesting tool. If there is anything that you didn't understand, please write in the comments so that I can help out to explain something, or maybe even create a separate new video explaining some of the concepts that I've done here. Thank you so much, and until next time.